The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
When you have a group of 2 or 3, come grab a soldering iron and your solar cells from me and choose like somewhere in this room to work. We're staying in here for
Do you want us to overlay it?
Don't touch this.
Oh, you're not actually soldering directly. Yeah, you don't want to overlay it.
Okay.
Okay. So these 3 contacts will be parallel and these will be in series, right?
Yeah, so you generally want to go like the way you would generally do it is you would. So I think it's less critical that you cover this entire set.
Okay.
So if you cover a little bit of it and solder to that, and the back is also like all of this is conductive. The only reason the tabs are there are because the tabs are easier to solder to, and so it's just more convenient. And you don't really need to solder to all of them individually. You can only solder like at minimal. If you wanted to solder, like do it really minimally, you could just do like a solder from or a wire from there to there, and that would work. Like that would be fine. But the reason that they have a lot of them is because if something cracks or something like that, and you can't tell if you have a wire running across, your wire's not going to crack because these are fragile. And so you have more. You also have more contacts. So, so you should feel free to wire it however you want, and then we're going to test them later too.
Is it not?
You have that sheet dialed.
Yeah, we dialed it up.
Put on. You want to?
Across these 2, right?
Or do you want us to cut it off in small strips?
I'm trying to think if that would work.
And connect these 2.
Yeah, but I don't know. Like I don't know if that would work.
It'd be a full circuit.
Yeah, but I don't know if you can do that across a specific cell. Like I feel like that wouldn't work because I mean it would definitely make sense if you took 2 of them and you did one way and you did the other was that you had them going in 2 different patterns on one side. So you were connecting positive to negative to positive to negative. And then on the other one you were connecting negative to positive to negative to positive.
That is on top. Yeah. That is on top. That is on top. That's great. It's on top. Like that. Right?
Yeah.
Yeah, do we?
That's how you would traditionally do it.
Oh no, it was Gwen that told us. It was Gwen that told us about like. Can you use those scissors?
Damn it.
Yeah. That's exactly what I'm talking about. Yeah. I hate that. And then it starts to burn the butter. Like, ah! So hard. It's actually the worst. Yeah.
I think it should be okay.
Do you have to do this side too?
You need more ribbon.
So you should also probably cut this shorter because this is electrically conductive, even though it's not tabbed, like the entire surface is electrically conductive. So if it's touching, it's gonna short.
So like this part, like you only need this one to touch. Is that what you're saying?
No, well, that is true. So the thing is that all of these are like this is all one surface that's electrically conductive. The tabs are just there to make it easier to solder onto, or supposedly make it easier to solder onto. But the thing is that if you have 2 of these like right next to each other, and they're like the backs, like there's a wire touching, like this wire is touching this, then you're gonna short your.
Okay.
So we just cut that part off.
Okay. So here you're going to do that part. All you need to do is from here, like this much length.
I heard something crack.
Uh-oh. Without.
Okay. So this makes sense to me. We do both. There could be completely wrong. So, Amit, are we supposed to do both sides? Like, are we supposed to have like both sides connected? Or not under like something? Is my and then have like one connect. Would I need a load for that? You got one?
These are really pretty in the sun.
So yeah, so when you're checking voltage, you need to like sort of do it in parallel, like check it across an element to see how much voltage is being dropped. So in this circuit, so you have this like battery, this is the source, and then the only load is this thing. And so this is going to be dropping all of the voltage that is being collected by the solar panel.
Getting anything?
Is it getting any current? You don't have any current this one. I mean yeah.
You're right, sorry. 2.36.
That's milliamps.
Volts.
Oh, volts.
Yeah, we're checking volts. Then you don't need the load.
Then you don't need it.
Yeah, because this becomes like the finishing.
Oh, so in that case, we're gonna still check.
Yeah, we'll
voltage
check the
for
voltage
one.
across just one.
Got what, 2.4 for the whole thing, right? So
Mm-hmm.
it makes sense. Excellent.
Nice work.
2.56.
0.58
across the whole cell.
What was the resistance?
100 ohms.
It should change it.
Yeah, yeah.
No, it was still wired across the board. Can we just go inside and do a data switch?
All those three numbers.
Yeah.
Okay, I'm sorry.
I guess there's six.
I don't think we.
Oh,
for
are
the
we
first
going
panel,
to
we
do-
didn't cover a quarter of it.
Are we going to do a cover on one of these? The same thing.
Do you want to just cover the quarter panel for the first one? We didn't actually do that.
Sure, let's do that. We just covered one entire cell. Same effect.